Alright, so let's do the problem set number 1. So we do actually have the 7 questions that's going to be fairly similar to the in-class workout. So let me just try to solve all these problems. So that one right there, let me just try to make sure that my pen actually works. Okay, good. If I write the molecular formula, then that will be C4, because carbon says 1, 2, 3, 4, right? 4 of those. And then I have 3, 2, 2, 3. So that one is going to be H10, right? That's called the molecular formula. And if I write the empirical formula, this one turns into C2H5, because 2 divide both of these guys, right? 4 divided by 2 becomes 2, and 10 divided by 2 becomes 5. Now that I cannot divide this guy and that guy at the same time, except one. So that one right there is going to be the empirical formula. And as far as the chemist, being a chemist, empirical formula is not that important. We actually care a lot more about the molecular formula. The engineering people works with the solid, actually work with this guy, the empirical formula, but for the chemist we don't really care too much about it, so we're just gonna ignore that one from this point on. So let's just do the rest of the problem. So in this particular molecule right here, how many proton is in it? So each carbon have 6 protons, right? So that one right there is a 24, and then each hydrogen is going to have 1 protons, so that's going to be 10. So if I add these things up, I have 34 protons. And mass of the carbon is 12, right? Mass is 12, so let me just write that. Number of proton plus number of neutron is equal to mass of atom. Mass atom. We don't care about the mass of electrons because they're too light. So I know that mass of atom is 12 for carbon, and then I know the number of proton is 6. This is from the periodic table. Then I can solve for that guy, which is going to be 6, right? So once again, the carbon, let me just try to erase the proton right here. So now we are working with the neutron. I have 6 for each one of these guys, so that's 24. And then I have 0 neutron for the hydrogen, so it's going to be 0 times 10, which is going to be 0. So if I add these things up, then I have 24 neutrons. So that's now how many neutrons I have for this molecule. And then the number of electrons, see this one right here, I have 0 charge, right? So that's indicating that I have an equal number of electrons and protons. So that one right there is going to be automatic 34 electrons. So 34 electrons, 24 neutrons, 34 protons. So that ends the first part of the problem. Alright, then let's do the next problem. It's good. Alright, so if I actually have 500 grams of this guy, how many more? To do this type of calculations, I really have to calculate what is the molecular weight. The molecular weight is each carbon weighs 12 grams per mole, right? 12 grams for each carbon, and then 1 gram for hydrogen, right? So I have 4 times 12 plus 1 times 10. That's the molecular weight, so it's going to be 48, 10, 58. 58 gram per mole. Now, so each 1 mole weighs 58 gram, right? Then the how many moles of this guy is in 500 gram? So I have to divide by 48, right? So let me just try to calculate this one in Excel. I want to expose to you guys as much as I can with the Excel. So just right, that's good. So equal 500 divided by 58, sorry, 58, right? So 8.621. So I made a mistake. This is 58. That's 8.621 mole. Right, good. Now, mole of the butane, the C4H10. So I haven't really solved the problem yet, because this guy is actually asking me how many more of carbon atoms, right? How many more? And each mole of this guy, there are four carbons, right? So I need to multiply this guy by 4. So let me just do that. So equal A1 times 4, A1 being 8.621 times 4. Alright, so that's the number of mole of carbon, so 34.5 mole of carbon. Good. So we are done with quite a bit of a problem. I feel like I'm spending way too long time for the erasing the problem. So I'm just trying to get that moving around all the way to somewhere around here. Okay, good. And let's do the next problem, problem number 6. So 500 gram of that, how many carbon atoms? So in this particular problem, I didn't say anything about the mole, right? We were talking strictly about number of atoms. So each mole is like a dozen, right? Except it's this number, 6 times 10 to the 23. Should I actually go with a little bit more numbers? Okay. 6.022. 6.022 times 10. That's the number of mole, right? And I have 34.5 of them. So I have to multiply all these numbers. So we just try to write out is equal to that number multiplied by 6.022 e to the 23. That's a 10 to the 23, okay? Or should I actually write out with a 10 6.022 times 10 to the power of 23, right? Then I can actually multiply these two numbers. It's gonna be same. I'm just trying to show you guys what I'm doing with Excel. So this number multiplied by that number is gonna be that, right? So that's the number of carbon atom I have. 2.07 times 10 to the 25. So that's equal to 2.07 times 10 to the 25 atoms. Carbon atoms. Okay, so that's that. Now the last problem is slightly more interesting because I don't really have a mass directory for this one. I have a density and volume, right? And then I'm supposed to get the number of mole of carbon atoms. So in chemistry, you are either dealing with the number of mole of something or the mass is more important. So the number of mole of something and mass, right? So I really need to change this density and volume to mass first. So density right here is given as 573 gram per liter, and I have 2 liters, right? So just give you the density multiplied by volume is gonna be mass, just because of the density's definitions. Density is mass divided by volume. Mass divided by volume, right? So if I actually multiply volume on both sides, then you get this formula right here, right? So I gotta do that one. So density is 573 gram per liter multiplied by 2 liter. So liter and liter matches, right? So I don't really have to do anything here. So 573 equal 573 multiplied by 2. That's the number of gram I have. Alright, then what is number of mole of this butane I have? Remember that mass molecular weight was 58, right? So I'm gonna divide this number by 58. I shouldn't be doing this. Should probably write it somewhere around here. Is equal to this divided by 58. I'm dividing the total mass by the molecular mass, molecular weight. So that's the number of mole of the butane, number of mole of butane, Okay, and each butane contains 4 of those 4 carbon atoms, right? So I'm going to multiply this number. Should be multiplying this by 4, right? Because here each butane molecule have 4 of those, right? So I have this many mole of carbon. So that's complete the how you solve the in-class workout.